stage where we can look at construction. So we'll start with the construction for adversarial indistinguishability. So the indistinguishability based definition. So this is the simplest sort of definition we have, right? And what does the definition say? It says, so how does the construction go? The construction uses a primitive called a pseudo-random generator, okay? So the definition of a pseudo-random generator is as follows. So suppose L is some polynomial and G is a deterministic polytime algorithm such that when you give it an input S, the algorithm produces a string of length Ln. Okay, so you give it S of length n, it will produce a string of length Ln. Now, we call such an algorithm G a pseudo-random generator if the following two conditions hold. So first of all, it has to expand, which means that the length of the output string has to be greater than the length of the input string. And second is the pseudo-randomness condition. So what this says is that for all PPT distinguishers T, so all polytime distinguishers, there has to exist a negligible function such that when the distinguishers are given a truly random, or when the distinguisher is given a truly random string versus when a distinguisher is given the function G acting on a uniform string, then they should not be able to distinguish which is the case. Okay, so in particular, they should not be able to output 1 with non-negligible difference in the probabilities. Okay, and this function little l is called the expansion factor of G. Okay, and this is a very nice primitive because it turns out that one can construct this primitive using what are called one-way functions. We look at these in a little bit in some future lecture. But suppose that such an object exists, okay, then here's how you would construct a scheme which has indistinguishable security. So the idea is basically the same as a one-time pad, except that instead of using a large key, we will use a smaller key. Okay, so suppose that you have a pseudo-random generator with expansion factor L. Okay, then the scheme is as follows. So gen is going to sample a key k from n-bit strings at random and call it its key. Enc is going to take an n-bit string k, a message m of length ln this time. Okay, recall earlier it was only n in the one-time pad. Here it's ln. And the encryption is essentially the same as the one-time pad, except that instead of XORing with the key directly, you first apply the pseudo-random generator on the key and then you XOR it. And decrypt is again similar. You have the key, right? You have the ciphertext. You essentially do the XOR, but now with the ciphertext, and you'll get the message back. Okay, and the theorem says that as long as the pseudo-random generator is secure, then this construction satisfies our definition of private key encryption, which satisfies indistinguishable encryptions. This definition over here, right? So that's what the arrow was pointing to. Sorry. Okay, so that's the construction for indistinguishable encryptions.